back. Welcome back to Crazy Gamers Games and Electronics Videos. Today we're going to be working on Experiment 2 in our Make Electronics series, which is about basic electronics and things like that. This one, in the last video, I said some of the things you were going to need um, was a fuse, some fuses. Um, this is basically we're going to abuse a battery, is what we're going to do here. So we are going to abuse a battery, and it recommends using a small battery. We're going to use a AA battery. We need a few things. A battery carrier, a 1 amp fuse, two of those. Make sure you wear some safety glasses, and some alligator test clips, which are like these. These all come in your component kits if you have a component kit. If not, you can just pick up what you need for the experiment. And I mentioned what you needed in the last one. So right now I'm going to mention what you need in the third experiment. So when the next video comes out, you'll be ready. The next experiment is experiment 3. You're going to need a 9-volt battery, a 470 ohm resistor, a 1K resistor, and a 2.2 kilo ohm resistor. Just a regular generic LED. The alligator clip test leads, you need 3 of those, and then of course a multimeter. They're very handy. So that's for the next video, but let's go back to this video. This basically starts out with putting a battery into a holder and twisting the ends together, shorting it out. And this will generate heat from the chemical reaction because you're putting a dead short across the batteries. I would only recommend this with a alkaline battery. I would not recommend it with any kind of rechargeable battery. And you do this experiment on your own risk because shorting out batteries can be dangerous. But we're going to do it in a safe manner here. And then it goes on to talk about current and how resistance limits current through, and the current flowing at high rates is what makes things get hot. And then it goes back to touching the 9-volt battery on your tongue and why your tongue didn't get hot. And it's because of the high resistance in your tongue. And then it goes on to talk about basic voltage. Um, we are going to mostly use DC voltage, but the voltage in your house is 120 volts alternating current. That is not to be messed with, so I wouldn't mess around with that. Volts can be measured in millivolts, volts, and kilovolts, where a millivolt is 1,000 millivolts is 1 volt, and 1 kilowatt is 1,000 volts. And then there's also, it also talks about the fundamentals of amps, which is the measure of current, and that can be measured in microamps, milliamps, and regular amps. And 1,000 microamps equals 1 milliamp, and 1,000 milliamps equals 1 amp. Most of the time we'll be working under 2 amps and in the milliamp range most of the time, and occasionally the microamp range. And then it moves on to talk about fuses. And there's different type of fuses. There's the blade fuses that you would see in a car, and then there's glass cylinder tubes that are on various things. And then also talks about how circuit breakers are like a fuse for alternating current. So that basically is what it talks about. It goes a little bit between the difference between direct current and alternating current. Shows like what we get in our house is the alternating current at 120 volts. And then it tells us after we do this with the batteries, the one we shorted out, do not use that later. And the one we pop a fuse with is fine, but the blown fuses get thrown out. So let us move on to the experiments, because that's what we all came for. So we have a fuse holder. We have a 3 amp fuse. blade fuse. We have some 6 by 30 millimeter glass fuses in 3 amp. And as you can see, I don't know if you're going to be able to see this, but no, definitely not. They have it written on there what their amperage is. These are 250 volts, but that's not important. And then we have a breadboard with a fuse holder that holds the 5 by 20 millimeter. So these are low amp fuses. These are 200 milliamps and 500 milliamps. So they're a little smaller rating. And then we have a blown fuse I tested earlier at 1 amp, a 2 amp, and a 1 amp. And of course, the battery. So this is, let's see if this will show up. That is a blown fuse. As you can see, the wire is not connected. And I'll show you one that is connected. That is the wire connected in the middle there. So first we are going to take this battery and short it out. And hopefully the leads on my battery box are thick enough to they will allow that to happen. Because I tried using this battery holder to blow the fuses, but the wires aren't a high enough gauge to run enough current through. That's why I have the beefier unit connected. Okay. So I'm just setting up the camera here. Okay, so we'll put the battery in the battery holder, and then we will take a look at it here. Move that out of the way for now. We will take a look at it on the camera, as you can see there. And, oh no, you can't see that. There's the battery, and you can see that it's pretty cool. We will put a center point. We will put a spot, 2 spots, right there and right. So the battery is 20 degrees C. Line it up. So let us twist these together and see what happens. We want to do that quickly. So it says to wait a minute, and well, as you can see now, the wires are already hot. Wires are already 30 C. And you can see the connectors starting to heat up on this side down here. So we're watching. Yeah, the wires are definitely getting warm. So we're looking at 40 C, 44 C, almost 50 on the wires. But the battery doesn't seem to be getting hot yet. And it says to wait another minute, and then the battery should be getting warm. But it's not really, but the wires are definitely hot. About 54 degrees Celsius. Okay. I don't think the battery's going to get hot. I don't think the leads are thick enough for that. So what I'm going to do is I'm going to cut these off so they're no longer shorted. Okay, and then I'm going to just pull them apart. So they definitely got warm to the touch. The battery didn't really get that warm. I'm assuming if I left it on there for too long of a period, it would have heated up, but no reason to catch things on fire. Then we'll just go ahead and check the voltage of this battery here. It's still 1.2 volts. So it doesn't appear that we damaged the battery too bad. So that's that. Now let's see the power and current of one of these batteries. I'm going to take one of these 1 amp blade fuses and put it in my custom holder here and hopefully be able to zoom in on it. Okay. And I'll lower the camera. Okay, let's see here. Doesn't like that. Okay, now, as you can see, it's not blown, and what I'm going to do is I am going to short it across this battery, and it should blow. And you see it? It just melted right there. So we just melted that 1 amp fuse with a 1.5 volt battery. So let us try that. So we knew we put at least 1 amp through it. Let's see what happens to a 2 amp fuse. And we'll see if the 2 amp fuse survives. And the 2 amp fuse melted with a little bit of a glow. So that's 2 amps that this battery was able to put out. Let's try 3. Line that back up. Battery keeps moving. So it doesn't appear able to blow a 3 amp fuse. So in a short circuit, it can deliver a little bit over 2 amps, but not more than 3 amps, even over a period of time. So we're gonna zoom back out and we're gonna review here. Okay, so in review, we looked at different kind of fuses. We looked at how fuses blow with these blade fuses. And with these glass fuses, they have a little thin wire in them that basically melts and does the same thing. And you can put these fuses in line. They have these inline cables here that you can put in, and you stick your, like this, say it's 1 amp fuse, you stick it in there, and then you screw it together, and then we'll go ahead and put it across the battery. It was a 1 amp fuse, so it definitely should have blown, and then we can check it. And it definitely didn't blow it. Let's make sure. Yeah, this battery may be dead. Let's check it to see. Let's check to see if this is dead. No, it's still got 1.2 volts. I don't know why it wouldn't blow that. Some fuses are harder to blow than others. They take more of a time period. And as another example of types of fuse holders is this one. Again, this would be mounted on a PC board. It's got the little pegs, and then you can protect things in line, just like this is in line. You can protect them on your PC board, and you know the fuse just pops in and pops right out. You know, if you blow it, you need to go with a higher value. I don't recommend, if you are blowing a fuse that is the recommended fuse, there might be a product that is drawing too much current on startup. I wouldn't recommend shorting the fuse out or ever putting a larger fuse in unless you diagnose the circuit correctly. So that's it for this experiment too. And we talked about fuses. So in the next experiment, we're going to build our own circuit with some 9-volt batteries and some LEDs and some resistors. So stay tuned for that. For Crazy Gamers Games and Electronics, I'm the Crazy Gamer. Have a great day.